All right, so I'm going to be going over problems 5 through 8 for the 4.1 Trig Identities worksheet. So here we are, number 5. So you have cosine squared y minus sine squared y equals 1 minus 2 times sine squared y. So in this problem, there's a few different ways to approach this. You could kind of work with either side. I think the more straightforward way here is to work with the left side. At least that's the way that I'm viewing it personally. So here with the left-hand side, I'm noticing based on the right-hand side that I need everything in terms of sine squared. So I can use one of my Pythagorean identities to change this cosine squared into 1 minus sine squared. So I end up with 1 minus sine squared y. That's replacing the cosine squared y, right? Using this form of the Pythagorean identity, minus sine squared y. And then obviously here we have like terms. We can put those together into 1 minus 2 times sine squared y. And there we go. Went ahead and made the right-hand side, or the left-hand side is now matching the right-hand side, and we've established this identity. There are other ways we could have gone about this. We could have maybe tried to make the right-hand side match the left-hand side. So maybe I should try to see what I can do with that. The only thing that really comes to my mind right now is not super obvious, but to replace the 1 with sine squared plus cosine squared. So if we do that, we end up with sine squared y plus cosine squared y minus 2 sine squared y. Again, I'm replacing 1 with this identity here. And now you can see if I combine these together, I have 1 sine squared y minus 2 sine squared y. I'm going to end up with cosine squared y minus sine squared y, which does actually match. So it kind of works either way. I think the first way that I did it was a little more straightforward, though. All right, let's go ahead and move forward to our next one here. Next page. All right, so we're going to probably want to make use of that those identities that we had on this page. So let me get these here. Let's see if I can get these onto the next page. Okay, perfect, I can. So making use of some of these Pythagorean identities is probably going to be useful here. The reason I know that is just simply looking at it. I have squared trig functions, and that kind of leads me to believe I may want to use that. All right. So I have tangent squared x times sine squared x equals tangent squared x minus sine squared x. All right, this is a little bit tricky. A few different ways that we could go about this. I need to either change it from multiplication into subtraction. And so I could sort of get subtraction involved in a few different ways. I could either replace tangent squared using one of my identities here. Let's see. So I could replace tangent squared with something that involves subtraction there. I could also replace sine squared right here using this identity with something else that involves subtraction. So both of those sort of seem like they maybe are options here. Looking at this one, I could actually rewrite the right-hand side in terms of sine and cosine and do a little factoring, because I'd have sine squared over cosine squared minus sine squared. I could factor out a common sine squared, 1 over cosine squared minus 1. So something like this, and I could maybe see how that becomes something. That's sort of an option. I like working with the left-hand side though, but there are promising results for either way. So let's go ahead and make use of this first thing that I talked about. So replacing tangent with secant squared minus 1. Let's just see what happens with that. So that's going to be secant squared x minus 1 times sine squared x. In this case, I am going to go ahead and write this in terms of sine and cosine. So I'm going to replace that with 1 over cosine squared times sine squared. Okay, kind of see maybe where this is going. I'm going to distribute this in now. See what that looks like. We do want to keep in mind what we're going for. We're looking for two trig functions subtracted here. So we want to kind of put this together a little bit. So sine squared times this is going to be sine squared x over cosine squared x minus sine squared times 1 is just going to be sine squared x. Okay. Let's look where we're trying to get to, right? Pay attention to that always. So we have this minus sine squared. We already kind of have that accomplished. We just need to show that this over here is actually equal to tangent squared. And it is. This is just our basic quotient identity for tangent. So I can replace this with tangent squared x minus sine squared x. And there we go. We've verified this identity as well. I think this would have worked in many of the other ways that we were talking about. And so I can kind of briefly show one other method for this and go a little bit faster, but let's talk about making that substitution right here for sine squared instead. Just kind of see what happens with it. So that becomes tangent squared x times 1 minus cosine squared x. Again, this is replacing the tangent. Kind of distribute this in. We get tangent squared x minus tangent squared x times cosine squared x. Okay. I'm going to go ahead and rewrite. So this is what I want. I want tangent squared first. So I'm going to rewrite this and see if we can make it simplify to be sine squared. So tangent squared is sine squared over cosine squared times cosine squared. So hopefully you can see right here, cosines cancel out. The only thing we're left with here is sine squared x. And there we go. That worked as well. So just kind of another way to do it. Again, I'm just kind of showing some work here in terms of multiplying those tangent squared times cosine squared. Just kind of showing what happened there, how it reduces down into sine squared x. Either way, both of those methods worked, and you could also achieve the same thing with that factoring method that I talked about briefly at the beginning, but that's a little bit more complicated. All right. Let's go ahead and, move forward to the next one. Oops. All right, so number 7 here. So we have secant divided by cosine minus tangent divided by cotangent. Interesting. So in this case, I think we want to try to put these together. But first, let's see if we can kind of do a little bit of simplifying. So let's kind of take a look at it. So secant is really 1 over cosine divided by cosine. Interesting. Okay, so that's interesting in terms of what we're going to get there. Tangent is sine over cosine divided by cotangent, which is cosine over sine. Okay. Instead of division, instead of these big fractions here, let's change this to multiplying by the reciprocals. So for this one, we're going to get 1 over cosine times the reciprocal of cosine, which is 1 over cosine, minus, and then same idea here, we're going to have the numerator, sine divided by cosine, times the reciprocal of this, which is sine over cosine. All right. This one's not quite unfolding the exact way I thought it would, but that's okay. Sometimes they're a surprise. We end up with 1 over cosine squared minus sine squared over cosine squared. Few different ways to approach the ending on this. We could see if there's some Pythagorean identity that happens if I change this into secant squared minus tangent squared. That is an option, right? That's what these are equal to. So we could take a look at our Pythagorean identities, and actually there is a form of our Pythagorean identities that says that does equal 1. That's one way to go about it. The other way to go about it is even more straightforward. We have a common denominator here, so let's just put them together. It becomes 1 minus sine squared over cosine squared. We do know one of our Pythagorean identities says that cosine squared is actually equal to that. So I can replace this with cosine squared over cosine squared, which obviously does equal 1. So this one is a little more simplistic, keeping it all in terms of sine and cosine. But you could have noticed right here at this point that this is the same thing as secant squared minus tangent squared, which if we do go back a slide, let me do that. Let me try to go back. Yeah, right here, there is an identity. Secant squared minus tangent squared is actually equal to 1. So you could have noticed that one, again, at this stage right here. But you can always just sort of carry it forward in terms of sine and cosine and get it done that way too. Okay, let's go ahead and clear this and keep moving forward. I don't see a significantly better way than kind of the two different things that we did there, but there's certainly possible other options there. Okay. And here's our last one for this video. We're going to talk about number 8. We have secant theta times sine theta over tangent theta plus cotangent theta, and that's going to equal sine squared. Okay, let's see if that makes sense. Let's write it all in terms of sine and cosine. So nothing is squared right now, so I don't see any Pythagorean identities to use. I don't see any obvious things that are going to cancel out, no factoring. Let's just see what happens with sine and cosine. So secant becomes 1 over cosine times sine. So obviously those are going to multiply and be sine over cosine, which is the same thing as tangent. Maybe that's useful, maybe not. On the bottom, we end up with sine theta over cosine theta. That's our tangent, plus cosine theta over sine theta. Well, okay. Usually in the denominator, if there's nothing that seems sort of obvious to kind of cancel out here, one of your best bets is going to be to get a common denominator and actually try to add these together. And so looking at our two denominators, the only thing we can get is just multiply each fraction by the other denominator. So we're going to multiply this one over here by sine theta over sine theta. Got to do the same thing to the top and the bottom to keep this as a valid thing. Same thing over here, but we're going to multiply by cosine on the top and the bottom. That's going to give us a common denominator of sine theta times cosine theta. And then on the top, we're just actually going to be squaring these things, right? Yeah, let's rewrite this whole thing for a second. Might as well just do the whole thing. So multiplying this together on top, we get sine theta over cosine theta divided by, now on the bottom, we're going to get sine squared theta plus, over here, we're going to get cosine squared theta. And we had a common denominator here of just sine times cosine. Sine theta times cosine theta. Yeah, okay, so I can see some things happening here. Hopefully we noticed right here, this is a great identity to have memorized. This is just equal to 1, so that equals 1. Yeah, so let's slide this stuff over for just a second. Okay. So if that equals 1, let's kind of rewrite this. So it's sine theta over cosine theta divided by 1 over sine theta cosine theta. Okay, I can kind of see where this is going. Again, we're trying to end up at sine squared. I can see that maybe some of this stuff will cancel out. We might end up with sine squared. Hopefully when we multiply, these cosines will cancel and these sines will just multiply together. But let's just see that happen using the algebra here. So instead of dividing these fractions, let's just change this to multiplication of the reciprocal here. So we're going to have sine theta over cosine theta times the reciprocal of this, which is sine theta cosine theta over 1. Okay, yes. The cosines are going to cancel. That's what we were kind of hoping for. Cosines cancel. Sine theta times sine theta, we're going to get sine squared. And that's going to be over 1, which obviously is just the same thing as we have right here. So we're able to verify that identity that way. There are probably other methods for this. that rely on some other techniques than what I just did there. But that was relatively straightforward, and all we had to do was use sine and cosine and a lot of algebraic techniques, combining some fractions together, multiplying reciprocals, things like that. All right, I'm gonna go ahead and stop the video here and pick it up for a third part for the remainder of the worksheet. See you guys.